So we are bringing everything together here, talking about the things that we have covered so far with solving. Um, so when we talk about the coordinates of a function, okay, like where it hits the x-axis, we have a bunch of different ways to say this. So one is, we call it the solution, okay, it's like the answer. We call it the zeros. We call it the roots, or we call it the x-intercepts. Okay, so we have all these different terms for these spots here. Then we've got all these different forms we've talked about. So one of them is vertex form. So we said a x minus h plus k. What can we see from here? Well, in all of them, the a tells us if it opens up or down. Okay, it's our leading coefficient. Okay, but this one tells us our vertex. Okay, so that's a way that we really like to see where our vertex is. When we are in standard form, okay, that a is the same. It's the same a throughout all of these, but c tells us the y-intercept. Okay, and we like that because it makes the y-intercept super easy to find, and we can tell from this one, can we factor? All right, and in our last form, which is factored form, so x minus, I'm just using random letters, x minus y, x minus z, we can see the roots or the zeros are at y and z, for example. And we use that zero product property. And I kind of have that written down, right? Solve for x. Why is it called the zero product property? And it's called the zero product property because zero, so it was supposed to be a zero, 0 times anything equals 0. Okay, so why do we set it equal to 0? And I've got it twice here, so I'm going to do, let's see, I'm going to do this one the right way in green. Okay, and I'm going to do this one the wrong way in red. And I'll show you the wrong way first maybe, because it should make sense why it's called the zero product property and, for example, not the 3 product property, right? This one is set equal to 3. So if we factored the first half, I would take out an x, and I'd be left with 2x minus 1 equals 3. And then using that same idea, I would say x equals 3, and 2x minus 1 equals 3. 2x equals 4, x equals 2. Okay, these are the answers that I would get if I used this, I'm going to call this one the 3 product property. It's not real. Okay, it's not real, and why? Let's plug this in. If x equals 3, right, that was one of our answers, we'd have 2 times 9 minus 3 equals 3. 18 minus 3 equals 3. Not even close. Okay, it doesn't work unless it's set equal to 0. Okay, so the zero product property, it works when it's 0. Okay, so that's why we always start by this, moving this over. Oops, not 3x, minus x minus 3 equals 0. Like ding, 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 ding. We need to use this idea of the zero product property. So I'm going to factor this using the AC method. It'll be plus 2x minus 3x minus 3. Minus 1, x plus 1. So I get 2x plus, it's not right, 2x minus 1 and x plus 1. If I set this equal to 0, meaning, for example, I run out of room like always, 0 times x plus 1 equals 0. So that is why I set this equal to 0 and solve. And same for this one. If it's the other way, 2x minus 1 times 0 equals 0. X equals negative 1. Try these out. Okay, what do you get here? And I knew I did it wrong because I just did this for myself. And then I checked the answers. So I'm going to make sure that this says 3 instead of 1. Okay, so 2x minus 3, so my x would be 3 halves. Okay, 3 halves squared is 9 fourths, times 2 is 9 halves, minus 3 halves is 6 halves. Turns out that that's 3. It works. You could do the same thing with the number negative 1. So I've got it here. You could be check it out. Check the green one, plug it in, check the red one, plug it in. It only works if you're set equal to 0. And that's what using the square root allows you to solve quadratics without setting it equal to 0. Okay, so using the idea of algebra helps us determine these things without setting it equal to 0 and using that zero product property. Okay, so what do I have here? I have set equal to 0, factor. This is the difference of squares. Let's pick a new color. X minus 3, x plus 3 equals 0. Then I set each factor equal to 0 and solve. And get my 2 answers. Remember, you always have to have 2 answers, no matter which method you use. Okay, solve by square root. Let's try this one. I've got x squared minus 9 equals 0. I am going to add 9 to both sides. Square root x equals plus or minus 3, which is the same as saying x equals positive 3 and negative 3. I wrote 1 again. Okay, you get the same answer. You get the same 2 answers doing this. Okay, so let's practice some more. All right, so next one we're going to do, I'm looking at this and I again see that I have different the difference of squares. So this one's going to factor into 2x minus 5 and 2x plus 5. Okay, here's where I notice some of us making some mistakes. 2x minus 5 equals 0. Add 5. 2x equals 5. X equals 5 halves is one of my answers. Same thing here. I need to say 2x plus 5 equals 0. 2x equals negative 5. X equals negative 5 halves. These are my 2 answers if I'm using factoring. Okay, if I solve by square root, I can add 25 to both sides. I'm going to divide both sides by 4. Okay, so here's where that square rooting comes in. So I get x equals plus or minus the square root of 25 is 5 and the square root of 4 is 2. Notice I get the same 2 answers. Okay, repeating this process with number 3. Example number 3. Can I factor? Well, first I'd have to set it equal to 0. And then I would factor a 2 out. Okay, this 2 just hangs out here. This 2 makes my graph really skinny, like super duper skinny. If the regular one was like this, that's a really bad drawing, but I'm just showing you it makes it skinnier. So it hangs out there and we need it, but it doesn't affect our factors. Okay, what if we use algebra? I don't have to set it equal to 0 because I'm using algebra. I can start right here. I'm going to divide both sides by 2. Okay, so I have x squared equals 36. And I get plus or minus 6. Okay, I still get the same zeros. All right, what about this one? Ooh, I notice when I'm doing this one that I have, this is 7x squared, and this is 1 squared, and this is 2 times 7 times x. So I think this is a perfect square trinomial. So I recognize this, and I'm going to factor into 7x minus 1 and 7x minus 1. Okay, this is a case where we're going to have that double root, right? 7x minus 1 equals 0. So I ran out of room. 7x equals 1. So x equals 1/7. But it has to happen twice, right? This is one where it's going to cross like this twice. Square rooting. So 4x squared, let's see, minus 14x plus 1. Okay, can you square root this one? Well, if I try like I have on the other ones, what am I gonna do with this? I can't square root that part. Okay, these that are trinomials do not work well for square rooting. Okay, so like as I'm looking through here, there might be some that try to trick me, but I can already see that this one I am not gonna square root because I have too many. I've got a middle term with that x, and it is not gonna work out for me to square root that. Okay, so just be aware that not everything works perfectly. All right, if I was factoring this one, I would factor out a 3. And I would also find that I think this is one that we miss sometimes, is that perfect difference of perfect squares with x squared minus 1. Okay, because 1 is a perfect square. This, with this 3, would make our parabola even skinnier than the other one that we talked about with the 2. Okay, and then I would set these equal to 0 and get positive 1 and negative 1. That doesn't look like a negative 1, so I'm going to rewrite it again. And then if I solved this, I get to do that wonderful thing where I don't have to set it equal to 0. Here's the deal. You still have to remember that squaring a number gives you both the positive and the negative sides. Okay. Let's see, purple again. Okay, I already noticed this. I felt like I was being tricked a little bit, right? So what do I have here? 9x squared plus 12x minus 12. Okay, so hopefully the first thing you see is that there's a GCF of 3. So now I have 3x squared plus 4x minus 4. Okay, so now we need to do that AC method. So 3 times 4 is 12. Factors of negative 12 that add to positive 4 are plus 6 and minus 2. Totally out of room, aren't I? And then I'm going to have my 3 hang out here. A bigger 3 because I'm going to factor a 3x out of this and be left with x plus 2. And a minus 2 and be left with x plus 2. Okay. Okay, so what's that mean? That my factors are 3x minus 2 and x plus 2, and then that 3, right? These would all be here. And I would solve, and I should take my big red square away so I can use this, but we're going to remember that I'm going to get x equals 2/3 and negative 2. And I'll put my big red x back through it. Okay, remember, because of that middle x term, we can't use algebra to solve. Okay, What about number 7? It looks so familiar. I'm thinking, oh man, I can do the difference of squares. But I can't because this is a plus. Okay? I actually can't factor this one. Okay, there are no factors of positive 16 that add to 0. So what do? Let's try this. Let's solve using algebra. Oh, I see why now, right? I had imaginary answers. Okay, so that's why I couldn't factor this one. Let's do orange. Okay, what about this one? Look at, I feel tricked again. I need to move this over, so I'm left with x squared minus 4x minus 5. Okay, we have to set it equal to 0. And this out here, oh man, that gets me. I need to remember, set it equal to 0. Okay, I get x minus 5 and x plus 1. 5 and negative 1 are my answers. Okay, can we solve it with algebra? Okay, no, because of that middle term, that x. There is no way for me to factor that out and solve it. Okay, the rest for you is homework.